Greetings, Saints, man. We're going to go ahead and get started with lesson 6.3. Gentlemen, I suggest if there's any video that you're going to want to watch potentially more than once, this is it. So, something that's come up previously is the following. We have a triangle here. Let me redraw this and make it a little bit better so I can connect these vertices. We'll call this triangle A, B, C. And here's my question. Where's the middle? How do we construct that middle? I think you guys have some different ideas, right? I mean, is it here? Is it here? Is it here? I mean, what constitutes a middle? And is it the point that's going to be closest to the sides or equidistant to the sides? Is it going to be the point that's going to be equidistant to the angles? What do we do? Like, how do we find that? So there's different ways that we're finding concurrency in these lessons, right? Concurrency being where we have three or more lines congruent. And here's two more ways that we're going to do so. So first one we're going to discuss today in this lesson is what's called the median, in which the median is a segment where the endpoints that are a vertex and a midpoint of the side opposite. So here's how we actually construct it. All right. So let's take another triangle. Call this guy ABC as well. Man, this thing's not coming out straight. I gotta work on my settings here to straighten out my polygons. So I have ABC. And we have the side BC is opposite vertex A. And with that, what we wind up doing is we have a midpoint here of BC, which is M, and then A is my vertex, and it's going to connect between these two. Oh, that's kind of a not very straight line. It's kind of swervy each time. I'll get it. Here we go. And if I connect all three of these, this is going to be my point of concurrency. I'm going to call this guy X. The name of this point of concurrency, if I create three medians that will all intersect at that same point, excuse me, that point of concurrency is called the centroid. We're going to go over this in class, the four types of points of concurrency that we have. Okay? And here is the definition of a centroid. A centroid is 2/3 of the distance from the vertex to the midpoint opposite the vertex, which is on the median. It's this. So, what I'm saying here is that we have AM, right? And that's my entire median. So AX is going to be equal to 2/3 of that entire distance, AM. Okay? So, for example, if I had, let's say this is entire distance right here, AM. Let's say AM is equal to 6, okay? AX would be equal to how much? Well, it's 2/3 of 6, right? So 4 sixes, which is going to be 4. All right? 2/3 of it. So, just something as a little example there. Let's do like another one of these here. Like, what if I had, um, if I had XM is 5, then AX equals what? And AM equals what? Okay? Well, remember, XM is equal to 1/3 of that entire distance. Right? If I go back here, I have this entire thing here, right? This is going to be 2/3 up here, and this is going to be 1/3 of it. Okay? So, AM is going to be how much? Well, if xm is 5, the entire ax, right, is going to be twice that, which is going to be, so we have to do ax, which is going to be 10, and then the entire thing would be 15, right? Because it would be 5, 10, oops, and then 15. All right. Next, and really our last thing, which is our final type of concurrency that we're going to show here. Okay. And it goes like this. It's from the vertex to the side opposite. Oh man, I'm really struggling here. Okay, the side, oh geez, really struggling. Vertex 2, side opposite. There we go. I can spell, I really can. Okay, to the side opposite perpendicularly. This is what is called the altitude. Okay, so here's how we form an altitude. Vertex, and I'm going to draw this height perpendicular. It's not a perpendicular bisector, right? Because the bisector, oops, what did I do there? The bisector would cut the side in half, right? But that's not what we have here. Instead, we have this altitude, which is from the vertex to that side opposite. So where the median was from the vertex to the side opposite halfway, this is from the vertex to the side opposite perpendicular. And it has a point of concurrency. It's our final one that we're learning here in this chapter. And this is going to be the first 4 questions on your next quiz. That's 10 questions, so 40% of it. You're going to have to identify. If I tell you altitude, you're going to tell me the point of concurrency is called the orthocenter. All right? So, here's a fun problem. You guys ready? It's going to take a little bit. We're going to find the orthocenter for triangle JKL. The J is -2, 4. K is 4, 4. And L is 1, -2. All right. Let's have some fun here. Now, I am never going to graph anything here. I should never have to. So what I'm going to have to do is where, if you guys remember the circumcenter problems, I had to actually calculate a midpoint as my point to use. All right. And then I was working with the the midpoint, and then I needed the slope of that side and perpendicular, and I created this equation. Instead, what I'm going to do here is, if you guys think about this, if I go from this vertex, if I go just from vertex J, the side opposite would have to be KL. So I'm going to find the slope of KL, and I'm going to need to find the altitude slope, which is going to be perpendicular, okay? What's great is that this is actually faster than the perpendicular bisector because I already have J. It's right here. So my slope of KL, right, which is going to be -2 minus 4, -6, and then 1 minus 4, which is -3. So -6 over -3, which is going to be 2. So then the altitude slope, which is going to be perpendicular, is going to be equal to the negative reciprocal, -1/2. Okay? I'm going to take the slope. I'm going to put it into my point slope. So I'm working from J, right? From J, -2, 4. So I'm going to say Y minus 4. So Y minus the Y is equal to this -1/2 times X minus -2, which is +2. So then I'm going to distribute. I have Y minus 4 is equal to -1/2 X. -1/2 times +2 is -1. I'm going to add 4 to both sides. So Y is going to be equal to 1/2 X. -1 plus 4 is +3. That's one equation. So that's the equation from the altitude line that goes from J. So let's work from another point. Let's work from, in this case, K. All right. So I'm no longer working with J, now with K. So my slope, I need to take the slope of the side opposite that just does not have J or K, does not have K, which is going to be JL. So the slope of JL. So it's -2 minus 4, -6, and then 1 minus -2 is +3, which is going to give me -6 divided by +3 is a -2. So then my altitude slope is the negative reciprocal, which is a +1/2. All right. So then I'm working with K. Y, it's 4 comma 4, so y minus 4 is equal to 1/2 times the quantity x minus 4. So y minus 4, got to distribute. -1/2 x, 1/2 times -4 is going to be -2. Add my 4 to both sides. So y is equal to 1/2 x. -2 plus 4 is +2. That's my other equation. Now remember, gentlemen, I have these two equations now. I have y is equal to 1/2 x plus 3. I have y is equal to 1/2 x plus 2. I'm sorry, it's -1/2 x, right? Let's go back up here to this. Gentlemen, this is actually one of those common errors. I talked to a few of you about this. This is transposition error, right? Got to make sure I copy down the right thing. If I don't, I'm cooked. So here we go. Fix it. Both things equal y. Therefore, they equal each other. I have -1/2 x plus 3 is equal to 1/2 x plus 2. And now I solve, right? I have 1/2 x to both sides. That cancels. I have 3 is equal to 1/2 plus 1/2 is just 1 whole, or x plus 2. Subtract my 2 from both sides. 3 minus 2 is 1, and that's my x. Then I'm going to take my x, and I'm going to plug it into either one, right? I'm going to plug it into the positive one right here. So I have y is equal to 1/2 times 1 plus 2. So y is equal to 2 and 1/2, okay? So here we go. I have my orthocenter. It's this coordinate. It's going to be 1, 2.5. And that's how we do orthocenter. You are going to have a circumcenter question and an orthocenter question on your next quiz coming up. So if you have questions, Saintsman, you're going to want to see me and talk to me during my office hours, and I can give you some extra practice, and we can grind and work on these problems, right? Good luck.